Hey everyone, welcome back to this new chapter. So, to talk about this chapter is majorly covering the fundamentals where we'll be picking one small feature and we'll be learning about decorator design pattern. One of the most frequently asked interview questions, you would be given a feature which you might have to develop. So, we'll not jump directly to what is decorator pattern. First, we'll see the problem, we'll design it, we'll code it. Then, we'll see what all issues are there in that piece of code. Then we would see what decorator pattern is and how it helps. And then we'll code it using the decorator pattern. So first, let's understand what the problem says is. Okay, so to talk about the question, we want to develop a small feature or a program which gives us or calculates the price of the car. Okay, now suppose you go to a car showroom. Now you went inside a showroom and you will see different cars, right? So let's say you go inside. Now you will see Baleno over there. I'm just picking the Maruti car's name. Okay. Next car, let's say Swift, and there could be many more. Just to keep it simple, we are taking just two cars for now. You can go ahead and buy that car, any car. You go and check the price, right? What happens is you take add-ons also. You can add additional features, for example, car mats, seat covers, right? Let's say insurance. So you can add all these things when you purchase a car and the cost will differ, right? And these are dynamic if you see. For example, if you may want to add insurance, I may want to add seat covers and mats. Somebody else would want to add all three. Somebody else would do not want to add anything, right? So how would you make a program that gives you the price of whatever configuration a user wants to see, okay, or purchase? I hope you would have understood the problem, right? So like we used to proceed with every problem, let's build the class diagram for this. If we want to start, we'll see that, okay, everything is a car, right? Baleno is a car, Swift is a car, right? Both of them are different cars, right? So they would be sharing similar properties. Great. Now when we have add-ons also, for example, perfume in a car or seat covers in a car or maybe insurance in a car, then also the object is car, right? So let's make an abstract class car, and right now we just want the cost, so it will have a function cost. Now Swift can extend this base class car, so I'm writing abstract in front of it so that it is clear. So if you see, this is a relationship because we are extending the properties, and same ways there could be Baleno, and since this is also is a relationship, since we have extended, so we'll have to implement this cost function. Okay, so let's say this returns cost of, let's say, 5 lakhs. Same goes for Baleno will also implement this cost function which we have, and let's say it returns 3 lakhs. Okay, it will have to implement the cost function. If you see, there are more cars, right? Baleno with seat covers, somebody can else ask for it, right? So Baleno plus seat cover, right? This class would also be there because people can ask for it. There are all, again, different permutations and combinations also over there. So there could be Swift plus seat covers that will implement its own cost. So basically, how many permutations and combinations we can see here? So right now, if we see, there's one Baleno, so basically two, and we have sort of three additional features right now, right? We have three additional features. Okay, so how many classes will we have to make? Okay, so if this simple permutation, so a person would choose one base class, so 2C1, and a person can choose all of them. So basically there would be 8 combinations, I feel, so which equals 16 total classes. So there would be 16 classes which we'll have to make like this, right? So if somebody would ask for cost, we can return the cost. Great. Now let's see this code. If we see this code, total of 16 classes is there. Is this code manageable? Is this class diagram, if you see from the class diagram, of course, you would be able to code it, which would be simple. Is this complete program manageable? Think about it. I think this is not. Why? Suppose going forward, there's one more car. Let's say it comes Desire. Okay, there's one more base car that comes in, and there's one more additional feature that comes in. Okay, now you have the ability to buy perfume while you are buying the car. So then what would you do? So you'll have to then make desire with all these 4 new features, right? Which means how many new classes will you have to make? So you'll have to make all in all 16 new classes because 4 things are there. Simple permutation combination. 16 new classes you'll have to make, right? Which would be looking really bad code, right? If you see, this would be really bad. And this is called class explosion. Okay. So if we see, this is called class explosion. To prevent from class explosion, we use decorator pattern. Okay. So let's see what decorator pattern is. Before going to decorator pattern, I hope everyone would have understood what the issue is. Okay. If you have any questions till now, please post in the discussions panel below. We'll try to answer them as quickly as possible. Okay. Now, so what is decorator pattern? Okay. So according to decorator pattern, there's base and then there are decorators. Let's make a base class. Okay. So the base is car, which would be abstract. So this would have a function cost in it. So who would extend this class? Baleno and Swift would extend this class, Baleno, and it will have to implement the cost function. And now we have the Swift car. Since it has extended this, so it will also implement the cost function. Now, to talk about all the decorators we have, we'll make a decorator class. Why are we making the decorator class? Let's see it from a diagram first, and then we'll come back to class diagram again. Okay, because till here we are doing the same thing which we did previously, but now is the change that we are making a decorator class and we'll use seat covers and all of them as decorators. So let's see why are we doing this. So if you see that we have a base car, right? Base car. Then when we decorate it or when we add seat covers to it, then also this is a car. Now on top of it, suppose I added insurance also. Then also it is a car. Now if we let's say add mats also, then also it's a car, right? So we are decorating a base object. So this is a base. We are decorating it with few additional features, right? And this is then also final object is a car again. Now, what is this final object composed of? It is composed of base object. It has a base object. Again, focus on my word. What did I say? It has a base object. And after having the base object and after adding properties, it is a base object only. It is a type of base object only, right? So decorator will extend this base class, base car, and it has a object of base also. Okay. So it is a and has a relationship would be there. Okay. So since it has a, so it will have a car object. So we'll have to make it abstract. Since we are making it abstract, then only all the decorators will be able to extend this. Because we have, what all decorators do we have? We have car mats, seat covers, insurance, perfume. All of these are decorators. So we'll make it abstract. Okay. And we'll extend mats. Okay. We'll extend this decorator. And since this is a normal class, we have extended this. So we'll have to implement cost function. Why? Because this is an abstract class. It has not implemented the cost function. So the children would, have to implement it. Same goes for other decorators. Let's say covers, and we'll implement the cost function in this also. So to talk about relationship, this is a cover is a decorator. Okay, great. So this is a class diagram for a decorator pattern. So suppose someone says, okay, a user comes, he says, I want to buy a Baleno. Okay. So we made a new object of Baleno and I want to add seat cover over it. So what will we do? We'll surround it with seat cover. And now can you tell me the cost? So we'll call the cost function. Now let's see how does this give me the cost. So when I did new Baleno, it gave me the object of Baleno. It gave me this object. When I did new mat, what will it take? I'll have to pass a base object. Why? Because in decorator pattern, it has a base object, right? So I'll have to pass the base object. So I passed the base object. So which I passed as Baleno. Okay. So Matt would obviously, since it is extending, by extension, it has the access to this base car. So what would be the net cost? So what would be present in this cost function? So this cost function would be base car dot cost plus, let's say mats have a cost of 20,000 plus 20k. This should be the net cost. Same goes for cost of covers. Base car dot cost plus the cost of covers. Let's say covers cost around 10k. So base car dot cost plus 10k. This should give or return me the total cost of the car. Let's take one more example. Okay, so before this, let's just decide the cost. Okay, so let's say Baleno has cost of 1 lakh and Swift has cost of 2 lakhs. Mats have cost of 10k and covers have cost of 20k. Just the mats, okay, and just the covers. Okay, so let's take any configuration. Okay, Baleno plus cover plus mat. Okay, so let's calculate what would be the price according to us, not by the program, according to us. Baleno has a cost of 1 lakh plus mats is 1.1 10k plus 20k is 1.3 lakhs. So this should be 1.3 lakhs. Now let's go by the program. So what did we do? New mat, new cover, new Baleno dot cost. This will give us the cost. Now let's see how. First, a person asked me that, okay, I want a Baleno. So I made an object of Baleno. Now asked me to add cover to it, seat covers basically. So new seat, and because seat is a decorator, if you see, seat covers is a decorator. So I'll have to pass in the object of base. And what will it return? It will return me a base object only. Why? Because this is extending decorator and decorator is extending car, which is the base again. So this would return me base again. So this returned me a base car again. Now you asked me to add mats also to it. So what would I do? So new mat, what will it ask for? It will ask for a base object. On what did I want to add my thing? So I want to add my thing to this. I want to decorate this car, which is of base type. So car. Okay. Now I want to find the cost, right? So what will the cost? Cost would be cost of this plus Matt's cost was 10k. Now what is the cost of this? If we see it here, so cost of base car, which is 1 lakh plus cost of my seat, which was 20k. So this comes out to be 1.2 lakhs plus 10k is equal to 1.3 lakhs. I hope you would have understood this in a much better way, and we'll see the code also now. So let's, before moving on the code, what do you think about this class diagram? Is this extensible? Is this far better than what we had previously? Okay. Suppose going forward a new decorator comes. Let's say perfumes are also something which we would like to add on to the car. What all changes would you have to make to the code? There's only one change, let's say. Since you have to add perfume also to the car, so we'll make a perfume and it will extend this decorator class. That's it. That's it. This is the only thing that we'll have to do. Let's say tomorrow going ahead, we encounter one more base car. Let's say going forward, we get one more car like whatever, Desire. So we just have to make a class Desire and everything would be handled by its own. If somebody would tomorrow would ask me for give me a Desire with mats, there you go. You need not to make any change in the code. So I hope you would have understood this class diagram. If you have a little bit of doubts in your head, don't worry. We are going to the code and I'm pretty sure all your doubts would be cleared. So look at the code and we'll be coding from end to end. Great. So let's move on to the code now. Let's build some packages here. So let's build the base here. And of course, we are going to extend this base into Swift and Baleno. So let's make other classes also, Swift and Baleno. We are definitely going to have decorator also. So let's have a package decorator. Okay, so let's first make the base class. Okay, so we'll have to make this an abstract class. Okay, and we want to implement the cost function. So public cost, and this is going to be an abstract function. Okay, great. So Baleno will extend base. We should have named it properly. Actually, base would be named as car, but yeah, it's fine. Okay. Okay. Let's say if somebody asks me the cost of Baleno, so I'll return, okay, 1 lakh. Same goes for, let's say, for Swift also extends base. Okay. So let's say the Swift would return 2 lakhs. Okay, great. Let's make a decorator abstract. And we are going to have, let's say for now, we have 2 decorators or additional add-ons, seat covers and mats. Okay. So for simplicity, let's just name it covers and let's have mats. Okay, this is going to be an abstract class again. And by looking at the class diagram, it is going to have, or it is composed of a base class. So base car, let's say, and we can keep it protected so that its child classes can access this base car. And let's just, okay, why are we doing it in covers? I by mistakenly did it. Let's put it in decorator. Okay, great. So let's extend a decorator. Did we make decorator an abstract class? Yes. And we didn't extend actually. So we forgot to extend the base. So extends base. Okay. So yeah, let's go to covers and we'll have to implement the cost function. Right. So what would be the cost? So the cost would be car dot cost plus, let's say covers are having a cost of 20,000. So 20,000. Great. Same goes for mats. Mats is also extending. Extends decorator. Okay. So let's say mats are cheaper. Let's say they are 10,000. So, okay. So we're done with the program. Let's write a main function also and let's play around it. Okay. We'll keep the main function simple, nothing fancy, or we would not be handling exceptions here because that is not the main objective. Main objective was to see what the problems were. How did we overcome those problems and how did we learn decorator pattern? Okay. So scanners. Okay. So let's keep it doing till we have true here. Okay. So let's just publish messages saying press 1 for Baleno and press 2 for Swift. So system dot out dot println press 1 for Baleno, press 2 for Swift. So let's take an input, an integer. So int base car equal to scanner dot next int. We can use a case also here. So let's go right now. We just have to. So let's go ahead with if only if base car equals 1, which okay. So before going there, let's make a car class, base class, sorry, base car. Okay. So if we get the base car as 1, then this car has to be Baleno, right? So car equals new Baleno. Okay. Else if base car equals to car equals new Swift. Okay. And let's say if somebody presses some other integer, let's say, so we'll print a message, select valid number. Okay. And we'll continue. Okay. All of it will start again. Okay. So now we have got the base car. Let's add decorators also. Let's give them functionality to add decorators. So let's just have here press 1 for covers or press any other number. Okay. Cover equal to scanner dot next int. if cover equals 1, then we'll have, so what we'll do, we'll just enclose it or we'll add cover to it. So car equals new cover. What will we have to pass? Okay, I think we missed the constructor here. Yeah, if you see, we missed the constructor. So let's just generate constructor, because this has to have a constructor. And of course, we forgot to implement the constructor for, we'll have to implement the constructor for this also and for mats also. Great. So we'll have to pass in the base car. So which is my car right now. Okay. Same thing. Let's do it for covers. Oh, for mats. Press 1 for mats. If mats equals 1, then of course cars equal to new mats. Okay. And we'll pass in the car here. So now if somebody wants to get the final cost, so dot println, what will be the cost? So car dot cost. This should be the cost actually. Okay. Let's see and if this works. Let's say we want Baleno. Okay. If we want covers or not. So let's say we don't want cover. And if we want mats, let's say we want to add mats to it. Okay. So we see the cost has come out to be 1.1 lakhs. Okay, great. Let's play around with this a little more. So let's check Swift. Yes, I want covers also. Yes, I want mats also. So, okay. What is the costing for a cover? So cover is 20,000. How much does the mat cost? Okay. Mats is 10,000. And how much does Swift cost? Okay, it is 2 lakhs. So 2 lakh 30,000. Yeah. So cost is coming out to be right. Now, suppose going forward, you get that you have to add one more base car. So no worries. Just make a base car right here. Let's say Desire. And what you'll have to do, you'll just have to extend the base car, right? And let's say Desire is of cost 3 lakhs. And you're good to go. You just have to make a little change in your main function, but main function right now is just so that we can test or play with this a little bit. In actual program, you'll not have main function, you'll have API calls, right? So you'll just have to add one class here. If you want to add more decorators, let's say perfume, you can add more perfume. Let's play. If let's say we have added Desire, so let's say I will give an functionality to you to add to select Desire also. So 3 Desire. Okay. And okay, great. By the way, since it is getting so many if else, try to use case statements. Since initially it was really small, so that's why I went ahead with if else if statement, but try to avoid it. Use case statements. Okay. So let's see. Swift. Okay, I want covers. I don't want mats. So 3.2 lakhs. And yeah, this is it. This should be the value, right? So you see, we are able to extend the code. We are able to reuse the code. Our code is simple. Our code is manageable. And there's no class outburst also out there. So we have saved ourselves. So this is how decorator pattern helps. Let's talk about few more problems where you can use this decorator pattern. First of all, wherever the base is same and the final object is also of type base, always use decorator pattern. One more example could be pizza shop, pizza bill calculator. So if you go inside a pizza shop, you select whatever pizza you want to have. For example, margarita pizza, okay, tandoori pizza, veggie pizza, non-veg pizza. If you want to add more veggies to it, so decorators are more veggies, more jalapeno, more paneer, more mushroom, okay, extra cheese. So all of it is decorator, right? So pizza bill calculator could be one such application for this. If you can think of car servicing, where you want car washing, okay, so car washing bill calculator. If you want a premium wash or you want a basic wash, if you want your nuts and bolts to be replaced, this is again another decorator. If you want your mats to be dry cleaned, another decorator. So all of the features of this sort will use decorator pattern. So we'll be giving you the link for this repo also. You can clone it in your desktop and you can play around with this. You'll have the code also, and you can modify, or whatever changes you want to make to the code, you can see, check and test. Okay, I hope this would be clear. This is just a fundamental problem, okay, just to explain you what decorator pattern is. A small homework question also, since we are done with this. Like I said, pizza shop bill calculator, go ahead and implement it. This is a homework question. I'm giving it to you as an exercise. I hope this is clear. If you have any questions, please post in the discussions panel below. We'll try to answer them ASAP. So we'll see you in the next chapter. See you. Bye-bye.